Welcome to my channel Arun Kumar at Exam Guru. Today I will be dealing with the topics related to structural analysis, and I will be dealing with the questions on static indeterminacy. The first question is the number of reactions of the beam subjected only to vertical loads shown in the figure is option A 6, option B 5, option C 4, option D 3. Now let's look at the basics. What are the types of supports and the reactions? Supports are provided at the ends of the members. They are of three types, mainly fixed, hinged or pinned, and roller. In two-dimensional, there are three types of motion possible in a support. Number one, horizontal movement. Number two, vertical movement. Number three, rotation. We should note that the movements which are not allowed appear as reactions in a support. That is, if horizontal movement is not allowed, it will appear as horizontal reaction. If vertical movement is not allowed, it will appear as vertical reaction. If rotation is not allowed, it will appear as moment. Now let's look at each of the support and what are the reactions. Now let's look at the roller support, which is provided at the rightmost end. We assume the ends of the beams at each of the supports. Now what will happen to these beams at each of the support? If you look at the roller support, you can see there is horizontal movement and rotation. There is horizontal movement, there is rotation. But the vertical movement is not possible. So that will appear as vertical reaction. The roller support has only vertical reaction. Now look at the hinged or pinned support. What will happen? As you can see, only rotation took place and there is no vertical movement. There is no horizontal movement, which will appear as vertical reaction and horizontal reaction. Moving on to the fixed support. It will not support any types of movement which you have learned. That is, it will not support vertical movement, horizontal movement, and rotation. All the three will appear as reactions. Vertical reaction, horizontal reaction, and moment. All the three will appear in fixed support. Now let's look at the common examples of the type of support and the reaction. The most common example of a hinge support is that of a door hinge, which allows only rotation of the door. So this is one of the practical example to show the case of a door hinge. There is one more support which is not of use, that is guided roller support. What is the specialty of guided roller support? Only vertical movement is allowed. So far we have discussed the three type of support where vertical movement in any of these three supports were not allowed, but in guided roller support the vertical movement is allowed. But there is no horizontal movement and rotation. So what are the reactions that are coming on a guided roller support? It will be horizontal reaction and moment. And there is a free support. A free support is that support which allows all types of movement, hence there is no reaction in the case of a free support. Now let's look at the types of loading on a member. We have vertical loads, which is further classified into concentrated or point load, uniformly distributed load, which you can see the magnitude of load is same throughout the length of a member. We have uniformly varying load, which is varying uniformly throughout the length of a member. Then we have horizontal loads, which is acting on a beam. Note that when we consider vertical loading, there is no change in length of a member. That is an assumption that is considered in structural analysis, only in the case of vertical loads. And we have to note that there is change in length of a beam when there is horizontal load. As you can see here, there is a change in length. In case of vertical load, there is no change in length of a member, so there is no axial deformation. So axial deformation refers only when there is change in length. So when vertical loads are considered, we neglect horizontal reactions. In case of horizontal loads, there is change in length of a member, there is axial deformation. Horizontal reactions are considered in the case of horizontal loads because horizontal reactions involved in changing the length of the member. Now let's look at the types of support and the reaction. When we consider axial deformation for horizontal loads, we consider all the reactions which I have discussed before. Now when we ignore the axial deformation, there are no horizontal reaction. So comparing 1 and 2, we can see that in 1 there is horizontal reaction for fixed and hinged, but in the second case there is no horizontal reaction and this is the case only for vertical load, the second case. Now types of beams based on the supports. There is simply supported beam, there is cantilever beam, there is propped cantilever beam, there is fixed beam. Now simply supported beam, there is one roller and a hinge support. In cantilever beam, there is one fixed and a free support. In propped cantilever beam, there is one fixed and one hinged support. And in fixed beam, both the supports are fixed. In the case of overhanging beam, now this is the fifth case. Overhanging beam is the beam whose end extends beyond the supports and there will be at least two supports. So overhangs are marked as you can see here. So the beam is extended beyond the supports at both for the first case, and in the second case the beam is extended beyond the supports in both the ends. Then the next case is continuous beam. Continuous beam is the beam which has at least three supports, as you can see. The seventh case is overhanging continuous beam. When a continuous beam has a overhang, that is known as overhanging continuous beam. Now moving back to the question, the number of reactions subjected only to vertical loads shown in the figure. Now if you look at this figure, what type of beam it is a fixed beam. So the beam of the given question, and it is a fixed beam. Now we consider axial deformations for horizontal loads and ignoring axial deformation for horizontal loads. When we consider both the cases, in the first case, when horizontal load is considered, the fixed end has three reactions. And in the second case, the fixed end has two reactions. So the number of reactions in the first case is there are two fixed ends. So from the two fixed ends, 3 plus 3, 6 reactions will be coming. And from the second case, there are two fixed ends. So two reactions are coming, 2 plus 2, 4. Hence, the number of reactions of the beam subjected only to vertical loads. So when it is considering only vertical loads, the right answer will be option C, 4. Now moving to the second question, the number of reactions of the beam considering axial deformation shown in the figure is option A 7, option B 5, option C 4, option D 3. Generally, axial deformations are ignored in continuous beam, but for this given question, it is specifically asked to consider axial deformation. Now, when the axial deformation is considered, a fixed end has three reactions, a hinged end has two reactions, and when we ignore axial deformation, a fixed end has two reactions, a hinged end has one reaction. So as you can see, so the number of reactions coming is 3 in the case of axial deformation for horizontal load is 3 for fixed plus 2 for hinged at both the ends. So 3 plus 2 plus 2, that is 7. In the case of when we ignore axial deformation, it will be 2 plus 1 plus 1, that is 4. So for this question, the right answer will be option A 7. Now the third question, the degree of static indeterminacy of the beam shown in the figure is. Now what is degree of static indeterminacy? The beam should be first checked for static indeterminacy before analyzing and finding the reactions. The beam should preferably be statically determinate. Now what is the advantage of being statically indeterminate or statically determinate? When there is an increase in length of beam due to temperature changes, no additional reactions are developed at the support in case of statically determinate beam. We prefer statically determinate beam only for that case because there is no additional reactions when there is change in length. The beams will be statically determinate if the degree of static indeterminacy is 0. Before going into static indeterminacy, we should know what are equilibrium equations. Equilibrium equations are those equations that are necessary to ensure the structure remain at rest even after the action of external forces, moments, or torques. In 2D structures consisting of only xy plane, the external forces can act in x direction. Then the external forces can act in y direction. External moments can act in xy plane. Now sigma fx equal to 0 so that member remains at rest in x direction. Sigma fy equal to 0 so that member remains at rest in y direction. Sigma mxy equals 0 so that member does not rotate in xy plane. These are the three equilibrium equations. Sigma fx equal to 0, sigma fy equal to 0, sigma moment about xy plane equals 0. Now what are the methods to determine degree of static indeterminacy of a beam or frame? They are of two categories: considering axial deformation and without considering axial deformation, usually when only vertical loads is present. So these are the two cases. Now let's look at each of the cases. Case number 1, when axial deformations are considered, change in length of the beam due to loads are considered, horizontal loads are also considered. The formula is, first formula is ds equals small r minus 3 minus capital R. It is applicable for beams and frames without closed box. The second one, ds equals small r minus 3 plus 3c minus r dash, applicable mainly for frames resembling closed box. So as you can see in the right side, it's a frame having closed box. Number 3, ds equals 3m plus r minus 3j minus r. It is applicable for beams and frames without closed box, where r is total number of all the reactions coming from the support, capital R is number of internal hinge joints, c is the number of boxes in a closed framed structure, r dash is number of members adjoining internal hinge minus 1, j is number of joints, m is number of member. The number 3 in the formula, it indicates the three equilibrium equations, that is sigma fx equal to 0, sigma fy equal to 0, sigma m equals 0. Now considering the second case, when axial deformations are not considered, change in length of beam due to loads are not considered, only vertical loads act. There are only two formulas. The first formula is ds equals r minus 2 minus capital R, applicable for beams and frames without closed box. The second case, ds equals r minus 2 plus 3c minus r dash. It is applicable mainly for frames resembling closed box, where r is total number of all the reactions coming from the support, capital R equals number of internal hinge joints, c equals number of cuts required to make closed box open, r dash number of members adjoining internal hinge minus 1, j is number of joints. Now we know that there are three equilibrium equations: sigma fx equal to 0, sigma fy equal to 0, sigma mxy equals 0. If we consider xy plane and along the x direction, when we ignore these horizontal reactions, when axial deformations are considered, we ignore the horizontal reactions. There will be no sigma fx equal to 0. There will be only sigma fy equal to 0 and sigma moment equal to 0. These are the two equations that are considered for this case, particular case. Moving on to the beam given in the question. So this was the beam. R is number of internal hinge, which we'll be dealing in the next question. So it is 0 for this question. Next, C is the number of cuts required to make the closed box open. There is no box structure in this question, so the value of C equals 0. M is number of members. There is one member, that is AB. J is number of joints. There are two joints, A and B. So joints are nothing but it refers to supports. R dash, number of members adjoining internal hinge minus 1. Because there is no internal hinge, you can assume the value of R dash as 0. So you got capital R as 0, C as 0, M equals 1, J equals 2, R dash equals 0. Now we consider axial deformation and ignore axial deformations for vertical loads. These are the two cases. We note down the reactions. We know that fixed end has 3 reactions. Hinged end has 2 in the case of axial deformation, and when we ignore, fixed has 2 and a hinged has 1. So the total number of reactions coming in the first case is R equals 5. In the second case it is 3. Now ds equals small r minus 3 minus capital R. Small r is 5. So substituting we'll get 2 for the first formula. From the second formula, r minus 3 plus 3c minus r dash, we'll get the value as 2. And from the third formula, 3m plus r minus 3j minus r, you get the value as 2. Now similarly, when we ignore axial deformation, we get the value of ds as 1. And in the second case, second formula also, we get the value of ds as 1. Now moving on to the question, degree of static indeterminacy for the beam shown in the figure is, we have considered two cases. So this beam is subjected only to vertical loads. The axial deformation is neglected. So when the axial deformation is neglected, we got the degree of static indeterminacy as 1. So correct answer is option A, 1. Now the next question, the degree of static indeterminacy of the beam shown in the figure subjected to vertical load is option A 1, option B 2, option C 0, option D 3. Now if you look at this question, there is a hinge that is provided. This hinge is known as internal hinge. Now what is an internal hinge? Internal hinge are the sections within a beam that allow only rotation. The best example of internal hinge in our body is the hand wrist. So you can see that the hand wrist is rotating, or the hand is rotating about the hand wrist. Now internal hinges are provided in structures too. Number 1, reduce the degree of static indeterminacy to make a structure determinate. And number 2, to reduce horizontal movement in a beam, as internal hinge allows only rotation. Now the second point is clear, that internal hinge only allow rotation, it will not allow horizontal movement. So in order to reduce horizontal movement, we have to use internal hinge. Now the first reason we will be discussing now, that is reduce the degree of static indeterminacy to make the structure determinate. How it is possible? Now if you look at the presence of internal hinge, it is denoted by a ball. It is denoted by a ball in between the sections. Now we consider beam without internal hinge and a beam with internal hinge. And when it is subjected to loads, what will we observe? So we have observed that rotation is allowed at the hinge for the beam with internal hinge. Now what is the relation connecting rotation and moment? So if rotation is not allowed, there will be moment. If rotation is allowed, there will not be moment. That is the relation connecting rotation and moment. So that means moment at hinge equals 0 because rotation is allowed at the hinge. Now capital R equals number of internal hinge points for this given question. It is equal to 1. C is the number of cuts required to make the closed box open. There are 0 boxes, so the value of C is 0. M is number of members. So you can see there are 2 members, A, B and BC. Then the J number of joints, here there is internal hinge, so that we consider internal hinge in this question. So there will be 3 joints, A, B and C. And now R dash, the number of members adjoining internal hinge minus 1. AB and BC are the members adjoining internal hinge. There are 2 members, so 2 minus 1, 1. The value of R equals 1, C equals 0, M equals 2, J equals 3, R dash equals 1 for this given beam. Considering axial deformation and ignoring axial deformations, 2 cases. We know that a fixed end has 3 supports when we consider axial deformation and 2 when we ignore axial deformation. So the number of reactions are equal 6 in first case and 4 in the second case. Now using the formula dsr minus 3 minus capital R, we get the value of ds as 2, and we get, using the second formula, we get the value as 2, and using the third formula also we get the value as 2. Now when we ignore axial deformation, using the first formula we get the value as 1. The second formula you will get the value as 1. That is, when we ignore axial deformation we get the value 1. When we consider axial deformation we get the value 2. Now look at the question. The degree of static indeterminacy of the beam shown in the figure subjected to vertical load. So when it is subjected to vertical load, we will ignore the axial deformation. Second case, so second case we got the value as 1. And the correct answer will be 1. Now the fifth question. The degree of static indeterminacy of the beam shown in the figure is. Here also the hinge is provided. For this given question, the number of internal hinge joint is 1. The number of cuts required to make the closed box open is 0. Number of members are 2, A, B, B, C. Number of joints are 3, A, B, and C. R dash, the number of members adjoining internal hinge minus 1. That is 2 minus 1, that is 1. We got R as 1, C as 0, M as 2, J as 3, R dash as 1 for this question. Now considering axial deformation and ignoring axial deformation, we know that a fixed support has 3 reactions, a roller support has 1 reaction in the case of axial deformation, and when we ignore it, the fixed has 2 and a roller has 1. The total number of reactions in the first case R equals 3 plus 1, that is 4, and in the second case it is 3. Now using the formula ds equals R minus 3 minus capital R, we get the value as 0, and in this, using the second formula also we get the value as 0, and using the third formula also we get the value as 0. And when we ignore axial deformation we get the first value as 0, and the second, using the second formula we get the value 0. So we got the value 0 in all the 2 cases when we consider axial deformation and ignore axial deformation. Because its degree of static indeterminacy is 0, it is statically determinate beam. The degree of static indeterminacy of the beam shown in the figure is, so option C, it is 0. And it is an example of statically determinate beam, and the specialty of statically determinate beam is that if there is any temperature changes, then there will be elongation. When there will be elongation, there won't be any additional reactions that will be occurring at the support. So thank you. Like, share and subscribe my channel.